So I give you Dan with his talk on network protocol reverse engineering and then IoT hacking.
Throwing stuff. Excellent. You good? Yeah. Okay. Mic check, mic check. Good? All right, my clock says it's time to go, and this is going to be a very fast demonstration. My name's DanNagle, and this is Hacking Network APIs. And what we'll be doing is we'll be reverse engineering an app. We're going to acquire its data, we're going to replicate it, and we're going to rebuild that app from scratch. And time permitting, because it's a very fast demonstration, we'll unearth some malware with it. I'm going to be moving very... That better? Okay. So we're going to be reverse engineering an app and taking control of it and rebuilding it from scratch. You'll be seeing a lot of Wireshark, a lot of packet sender, and we're going to rebuild the GUI. I'm going to be moving fast because this is normally a 1-hour demo, but I've only been given 20 minutes, and I did not want to cut too much. So let's go ahead and get started. I'm DanNagle. I am a cyber engineer for Raytheon Codex. Rather than rehash my bio, you can just go online and look up and read it yourself. I do want to drop some links. rtx.com/codex if you want to read more about Raytheon Codex. And we are hiring, so if you're interested, you can go find one of my colleagues and talk to them. Packetsender.com is where you find the app that you'll see today. It's available Windows, Mac, Linux, open source, homebrew, Snap, all of them. And I know 20 minutes is a short amount of time, but if after I'm done you're thinking you would like more DanNagle in your life, you can go to DanNagle.com and see some of the less interesting stuff that I've been up to. So here's my setup. I have my laptop right here, and Packet Sender and Wireshark are running in tandem with the app that we're going to target. It's called PyPlayer. That's right here. I'm connected to my switch right here, which is connected to my Raspberry Pi. This keyboard's a Raspberry Pi, which is connected to my display right here. And all this is doing is outputting audio. There's nothing to see on here. So it is a network audio player that we're going to take control over, rebuild, and let's get started. So that is 3 slides. That's all I get. The rest is demo. So we'll launch PyPlayer app, we'll launch Wireshark, and we'll launch Packet Sender. Let's start with PyPlayer. Now, we need to reverse engineer these buttons. So let's click on the first button and see what happens. It found my Raspberry Pi. Now, how it did that, we'll find out in a little bit. But the next buttons, it will play. Can you hear that? Yes, you can hear that. Next, and stop. So what is it doing to accomplish this? We'll find out soon, but we need to replicate these 3 buttons right here. So let's go to Wireshark. I don't have time to explain Wireshark, but I'm going to put in a filter right here to save some time, UDP or TCP, and get started. Restart the app. Find the Pi. There, it found it. Play. There it is right there. Next, and stop. All right, let's see what we found out. Go up to the top. All right, it did a broadcast. It did a broadcast to port 15,000, and it sent some data. So that's what we need to replicate. And for the TCP connections, it also talked to port 15,000. So that's what we need to do with Packet Sender. Close that out. We don't need that anymore. So this is Packet Sender. It is a network troubleshooting utility. It's open source. You can download it at packetsender.com, or you can fork the code off my GitHub. It does a whole lot of things that I don't have time to explain, but hopefully you'll get the gist of it as I go through this demo. So we need to do a broadcast to port 15,000 UDP. And the data is find units. Send that. There we go. I know that's hard to read, but it replied back server address : and its own IP address. So that's the broadcast protocol, the discovery protocol that it's using that we just replicated. So for the next step, let me save this. 0, find pi. Just save that for later. Now, rather than Wireshark capture data, read it, and type it in, I'm going to put packet sender in the middle, and it'll just feed me its data. So we know that it listens on port 15,000. So I'm going to set packet sender to listen to port 15,000. And it's going to reply with the protocol that we discovered earlier. So rather than the Raspberry Pi replying back, packet sender is going to reply back using the protocol that we found. Now disconnect my Raspberry Pi. There, we caught it. He's now talking to me instead of the Raspberry Pi. I replied back with the protocol. Let's clear this out, and it's just going to feed me its commands, just like that. Play, next, and stop. So let's save that. 0 play. Save this command. 0 next. And save this command. 0 stop. There we go. Now I got to fix the IP address. It's 169. Now fix the port. We know it's port 15,000. There we go. Reconnect my Raspberry Pi. Okay, here we go. We'll close this out. Here we go. We recreated the app. All right. I promised you a GUI. I said we recreate the GUI too, and that's what we're going to do next. I got to put down the mic real quick to do that. So here we go. We want play, next, stop. I didn't click it. Play, next, stop, and we're going to recreate the GUI, just like that. All right, so this is not very clean. We want this to be a little cleaner. Call it play. So packet sender has a scripting interface that I don't have time to show you, but that's worth exploring. Stop. We'll save this. Call this pi. Take a look. Doing good. And we'll set it as the starter panel. This lets me do this. See, the problem is that as developers, when you develop something and you give it to the end user, you just want them to see this thing, because all they need to do is play and stop. You don't want to ship them this complex troubleshooting tool in the background if all they need to do is just click play and click stop. So we set it as a starter panel, and that lets us do this. Only launch the panel. So now, there we go. So we recreated the app. We don't need it anymore, and as a bonus, we can make it huge. All right. That was demo 1. I've got one more demo. We're going to move right along. This is a malware inside my Raspberry Pi that I'm going to unearth. Let this be a cautionary tale about what you're about to see. It's very dumb malware, so don't, It's actually simulated malware. Don't report me to anybody, please. To do this, we're going to start with a live capture. And I already see something interesting. All right, so it is ARPing for 192.168.0.1. What is that? That's my gateway. It can't find the gateway because this is an isolated network. So what I'm going to do next is I'm going to give it the gateway by assigning myself that IP address. So the address was 192.168.0.1. There we go. All right, we're in. Replay. Okay, it found the gateway, and now it's trying to talk to the internet, but it can't, because once again, isolated network is trying to talk to this random IP address, and it can't reach it. So next, I'll give it that random IP address. Let me move this over so I can see it. And it is 138.197.192.84. Go. Replay. Now we'll wait for it to fail again. There's the attempt, and then there's the failure. It found the IP address, but there's nothing listening on there. So if you were, it's the equivalent of in your browser going to a web address and it's saying connection refused. That's basically what happened. It's trying to talk to port 5123, but there's nothing listening on that port. So let's put something on that port. So I can listen to multiple ports by putting a comma right here. Do 5123. There, I already got something. It's right there. Let's see what we found. I know it's hard to see. Let me zoom in. It did an Nmap scan. So it scanned my network, and it did it on July 5th. This was last week as I was putting this demo together, and found all the listening ports. Now it's trying to talk up to the mothership, presumably to get commands for what to do next. And packet sender did not reply back correctly for it to know what to do, so it's just retrying, trying again. Now the next step would be to presumably figure out, have a mock reply coming back and just chase this to see how far it goes to figure out what it's planning to do next. So the cautionary tale is be careful which you're putting IoT devices on your network, and instead segregate it to a guest network because it could be doing Nmap scans. So that is demo 2. I know I moved extremely fast, but that was the intent. For the first demo, I want to make sure I mention mitigation strategies. If you notice, I did a UDP broadcast, and I got the response back. The way you would mitigate against that is that you would encrypt the data. You could do a standard symmetric encryption, but that would still open you up to replay attack, so you do symmetric encryption plus adding a sequence number. And then that would stop me dead, or would not be able to do my replay attack. For the command buttons that hit the network audio player, you could encrypt that also, ideally with TLS, because then it would refuse my connections from packet sender. It's an isolated network, so that makes TLS connections a little bit difficult, but you own both the client and the server, so you can work out something. I mean, worst case, you can also do symmetric encryption with the sequence number on that too. That would stop me there. For this talking out to the mothership, it should using some kind of cert, maybe a HTTPS REST call using Let's Encrypt or some other technique, and that would stop me there too. Or at least it would not send the data to Packet Center. So those are the mitigation strategies that would just knock my demo down into the dirt, and I would not be able to do anything. So I have a few minutes for questions. That was extremely fast, so please ask them. Yes.
Does Packet Center support TLS?
Yes, it does. You can even, right here down at the bottom, UDP, TCP, SSL, it even supports SSL on the server side. All you do is just choose what you want. And all these packets right here come shipped with Packet Center. It's about 30 sample packets, and some of these are SSL examples. Just do a search. See, here's one right here. I can't show you because I'm off the internet, but yes. It also has, and once you finish saving your packet, it also has a command line for scripting. Other questions? Okay. I will be here all day today. I'll be here all day tomorrow. If you do think of something, looking back on my demo, and thank you so much. I hope to see you around.